This is going to echo. I apologize. Solving logarithmic and exponential equations is sort of the culminating piece of what we've been talking about with logs. This is sort of the point of everything we've learned so far. Here's the problem with these equations. You know how normally with equation solving it's a very straightforward process? It's you do this, and then you do this, and then you do this, and then you have your answer. With log equations, there's so many different routes to take within an equation. There's so many different things you can do. You have to be a little bit creative, and you have to be willing to sort of try something, and if it doesn't work, try something else, okay? I'm going to try to give you some guidelines for when an equation looks like this, you could try this way. When an equation looks like that, you could try this way, okay? But really, there's a lot of different routes you could go about this, and probably there's more than one way. So if I tell you a way to do it and you've done it a different way, that doesn't mean that you're wrong, okay? So let's start with just some real basic ones here, okay? I have log base 2 of 3x equals log base 2 of 6. Now just on gut instinct, what do you think I could do here to get rid of the logs? Okay. Okay. What we did yesterday would be hard because we have one log equal to another log. Okay? And I can't, in my calculator, type in log of 3x divided by log of 2. Now, I guess I could, what Devin was saying is to do what we did yesterday. I could use that change of base property to do log 6 divided by log 2 and get a number over here, and then continue working with the problem from there. But I think there's a way that's a little bit simpler. If I have log of something equal to log of something else, what do you know is true about the two somethings?
They're the same.
They're the same, right? If this log, I guess I should do it so you can see it on the video. If this log is equal to this log, then this has to be equal to this. So when you have just two logs equal to each other that are the same base, you can just cross off the logs. And then you end up with 3x equals 6, which is really easy, right? Okay, 3x equals 6, so x equals 2. Divide by 3 on each side and you're done. Okay. So that second one, do I have two of the exact same logs? Okay, so I'm going to do the same thing. I'm going to cross this off and this off. Now the equation that I'm left with is a little bit harder, but I can work with this. How would you solve negative 2a plus 9 equals 7 minus 4a? Add what? Okay, so I would add maybe 4a to each side. You've seen in the other ones. There's only one log, right? So I can't just knock logs off. Zach, you with me? Okay. So let's think about what else I could maybe do with this problem. Any thoughts? Think about the very first thing you learned about logs. Dominic? Okay, I can't put it in for x, but I think maybe... Okay, except the 3 and the x right now are not being multiplied together. I see where you're getting that from.
Log negative 2 to the power of x equals 3.
Oh, close. Close, we're getting closer. D.
Just say it.
Almost. Okay, so what... Nope. What I am hearing from a lot of people is something about making a power, but just nobody has the right order of the power.
Log negative 2 to the third power equals
Nope.
x. Log to the x.
Okay, and hold on. Hold on.
Power equals 3.
Pause.
Log x.
Pause. When you're doing the exponent, it's no longer a log. Do you remember the very first thing we talked about was we took logs and we wrote them in exponential form? Okay? That's what we're going to do here. All right? Anna, do you think you know it? Okay. So what number is the base? No, the 3. So I'm going to say 3, 3 to the power of what? Okay, in a log, hold on. Let me tell you the right answer instead of guessing. in a log, the answer to a log is always the exponent. This is always the exponent. So it's 3 to the power of negative 2 equals x. Okay? I don't think so. I was listening for it. Now, Zach said 3 times negative 2. That was close, but I know, but I tuned you out when you just started babbling. So, okay, now this is easy, right? Now all I have to do is what's 3 to the power of negative 2?
9, negative 9. 9.
It is not negative 9.
9 to the 1 over 9.
It's
1 over 9.
What?
Remember, a negative exponent flips your answer over. Okay? So 3 to the power of 2 is 9, and then it would be 1 over that. Okay. So the second one, gentlemen, the second one we're going to handle much the same way, except we've got some other numbers floating around. What number do you want to get rid of first?
Negative 10.
Okay, so I'm going to add 10 to both sides. So now I have log base 3 of n plus 3. Please stop talking. Equals 0. Don't let that freak you out. So once again, I'm at a point where I have just a log equal to a number, just like I had up here. Log equals a number. And when you're in that situation, a log equal to a number, I would usually try to convert to exponential form and see if that helps. So what would this what would this look like if I were to write it as an exponent? What to the power of what? Look at the order that we did up here. What would we do here?
3 to the 0.
3 to the 0, there you go. So we would do 3 to the power of 0 would equal n plus 3. What is 3 to the power of 0?
1.
1, yep. So this would be 1 equals n plus 3.
That equals negative 2.
What's that? Yep, then subtract the 3. And you end up with, negative 2 equals n. Okay? So just like a lot of the other equation solving things we've done this year, start by clearing out any of the extra numbers that aren't in the parentheses or aren't in the log. Okay? So with this third one, what should we get rid of first? Okay, let's get rid of the 5. Subtract 5, because the 5 is not part of the log. So now I have, actually I might move this up further. Now I have negative 6 log base 3 of x minus 3 equals negative 24. What else you want to do?
Get rid of the negative 6.
How you want to do it?
Right.
Okay, this is negative 6 times log 3. So I would divide to get rid of it. And so now I have log base 3 of x minus 3 equals positive 4. And once again, I'm at a point where I have log equals a number. So what do you want to do from here? Okay, so I would go 3 to the power of 4 equals x minus 3. Remember, it's always base, exponent, answer. Base, exponent, answer. 3 to the 4th is 81, correct?
Yeah.
So 81 equals x minus 3.
84 equals x.
That is right.
Thank you.
Good?
What?
Questions?
No question.
Okay. So what I've got here are just sort of some general guidelines, and I'm going to add to this a little bit. I think I left this all printed in there for you, right? You don't have to copy any of this? Okay. So if you have just a single log in the problem someplace, I would move it around so that you have just log equals a number. And sometimes you're going to have to get rid of some other numbers, kind of like we did in that last example. We moved the 5, we moved the 6. Move it around until you have just log something equals something. And then turn it into an exponential and see if you can go from there. Okay, most of the time that's going to work for you. If you have just 2 logs in a problem, and this is like the first set of examples we did, 2 logs with the same base in the problem without any extra numbers. Okay, so I'm going to add that in here. 2 logs with the same base, but no other numbers. And to combine, you're going to have to use those properties that we talked about. Okay? If you combine everything into 1 log, so that you have just 1 log and then another number, then you can go about it this same way you were doing before. So if you combine into just 1 log and a number, you can go back up to this. If you combine so you have 1 log equals another log, you can come back up to this. Okay, so you're going to have to, like I said, just get a little bit creative. Okay? We'll keep practicing. What's that?
It's a song on YouTube.
Oh. Let's talk about one more thing. And actually, you saw this yesterday, but now we're going to be using it more frequently. Solving for x in the exponent. Okay? If you have an equation like this, if you have like a to the x equals b, so let me throw some numbers in there, like 4 to the power of x equals 12. Okay, and you're trying to solve for x. This is the process you're going to use. Now, sometimes you'll have some other numbers floating out there. Like you'll have a number that you have to add to both sides first, or divide by on both sides, something like that. Okay, you'll see some of those in a minute. But get it to the point where you just have this. Then you're going to take a common log of each side. And remember, when you take a log over here, when you take a log of a to the x, you're going to be able to pull that x down in front. All right? And then you can divide by logs to get rid of it. So it's kind of like what we did yesterday with the change of base property. Okay? In fact, I pulled this example right off your change of base property note. Remember yesterday we had this, 5 to the x equals 12. And we took log on each side. And then what did we do with the x? Okay, what did we do with this x right here? We slid it down in front, right? Okay, so we made an x log 5. And that's really the good thing about logs, that it lets you take that x out of the exponent and pull it down into the problem so you can actually work with it. And then we would divide both sides by 5. Okay, if I was trying to get x by itself, there should be division bars here. I don't know why they didn't come up. And then I could just do log 12 divided by 5, and I end up with 1.54. Okay? So that's what you're going to see on this next part. So for example, 3 to the power of x equals 10. What I would do, I'm going to slide this over, is I would say log of 3 to the x equals log 10. Okay? Which means then I could take that x and put it in front, so I would really write this as x log 3 equals log 10.
So just log?
Mm-hmm. Because why do I like this log? Why do I like just common log, base 10?
It's just regular log.
Yeah, but why am I happy about that? Put it in my calculator, yeah. Yeah, I can put those in my calculator. Okay? Mm-hmm. So then from here, what would I do if I was trying to get x by itself? Divide by log 3, right? Oops. Divide by log 3. Divide by log 3. Okay, and then you would have x equals, what is log 10 divided by log 3? Say it again?
0.477.
0.477.
I got 2.095.
It is going to be something over 2. 2.095 sounds about right.
Actually, it would be 2.096. I rounded it wrong.
Okay,
Yeah, 2.096. Yeah.
got it. Okay, guys, relax. The other thing you could do that, honestly, I had never thought of this, but someone in first hour suggested it. Remember how a minute ago we were taking logs and writing them as exponents? Well, you could go back the other way. You could take this equation that you started with and write it as a log. It would be log. What number would be your base? The 3 would be your base.
You sound like you're like the Wizard of Oz with that echo.
To the log base 3 of 10, and it always equals your exponent. Now, what did you learn yesterday about this?
I learned numbers.
You can,
Yes, you did.
you can, do log 10 divided
Log
by
10
3.
divided by log 3. Yeah, that's that change of base property. So you could rewrite it this way, and then wouldn't you end up doing this anyway?
Yeah.
Log 10 divided by log 3. So it doesn't matter to me which way you go about it. Okay?
Now, 3 is tricky.
Let's look at the second one. 5 to the power of x plus 3 equals 59. What do you want to do with that first? Okay, so first let's move the 3. Okay, so 5 to the power of x equals 56. And then I would take log on each side. And I'm doing that so that on the left I could write that as x log 5 is equal to log 56. And then if I were solving for x, what would I do?
Divide by x.
Divide by, not divide by x,
Divide.
divide by log 5.
$2.501.
Thank you.
Exactly.
Okay, so x is 2.501. Okay, questions on that?
The box. Yeah, so would you divide by 2?
You would divide by 2, yeah. Now, hey, let me point something out real quick. Common mistake here. I see a lot of people trying to multiply the 2 and the 5, and they make that like 10 to the power of x. Why can't you do that?
It's
Yeah, because the 5 has an exponent on it, right? So by order of operations, you can't combine those two things. So,
the X in front first.
you could if you took a log, but I wouldn't try to take a log with that 2 in front, okay? Because you would end up with more than one log in your problem, okay? So I would just divide by 2 first.
15.
So now you have 5 to the power of x equals 15. And now I would take that log of both sides.
Which is 1.683.
I'm screwed up.
You are one step ahead of me. Okay. This would then become x log 5 equals x log 15. Nope, not x log 15. What am I doing? Just log 15. Oh boy. Divide by log 5.
3.
1.6.
Hold on. Slowpoke over here needs to finish writing. Say it again.
1.683.
3.
You round.
683.
It's just really windy.
There we go. 1.683. Good? Okay. 2 things real quick. First of all, where you've got some space, do you have some space on the bottom there?
No,
Yes, you do.
I
That.
don't. I drew.
Oh, okay. Find some space. A problem, and I'll tell you right now, this problem is directly off your homework assignment. Okay? Because it's just like what we just finished doing, but it looks a little different, and I don't want it to freak you out. So I'm going to do this homework problem with you now, and then that way you already have it when you go to do your assignment. Okay, so write this down someplace. So,
Wait, why didn't you just give us the paper so we can
because I want you to have it in your notes. Okay? So, let's see. It is 11 to the power of x minus 8 minus 5 equals 54. Okay? So it still is a problem that has an x up in the exponent. So I'm going to handle it just like I handled that last slide of examples. Okay? What do you want to get rid of first? Okay, so let's add the 5.
The male.
But it's not May.
Clearly.
All right. We're losing focus.
There's man.
Thoughts about what to do from here?
Put 9 to the power.
Okay, well, take the exponent in front. Once I do what? What do I need to put in front of both of these? Yeah, I need to do log of both sides. That's what lets me put the exponent in front.
Yeah.
So yeah, so what's going to happen is on the left side here, it's going to become x minus 8 in front of log 11. And that's going to equal log 59.
Oh, I think I messed up.
Okay. So I took that, instead of just taking the x down from the exponent, I took the x minus 8 and put it in front. So that's where that came from. Then I'm going to do the same thing I did before. I'm going to divide by log 11. Divide by log 11. I'll need your help with that.
It's 1.700.
Yes, I got.
Okay, so now the only difference is normally at this point in the game you would be done. What do you still have to do? Yeah, so since you have x minus 8, let's add 8 to both sides.
9.7.
And so your answer would be x equals 9.7. Okay? So if you have other junk up there in the exponent, okay, if you've got other stuff going on up there, just move all of it down in front and deal with it after you get rid of your logs. Okay?